Now we're going to go ahead and add our fractions. The instructions might say something like simplify. Well, in order to simplify, we need to combine our like terms. We need to add these. So we need to get a common denominator. We have 5xy squared and 10x squared y. Let's see, they both share a 5, so I can take that out. I'm left with xy squared and 2x squared y. They both have an x, and if you want, you can go ahead and take the x and the y out. That leaves me with a y here and a 2x here. They don't have anything else in common, so here's my least common multiple. 5 times 2 is 10. X times x is x squared. Y times y is y squared. So we have 10x squared, y squared is our least common multiple, our common denominator. Y squared. Now we're going to use our trick to see what we need to multiply by. The first fraction had a denominator of 5x squared y, so it needs to get multiplied by 2x. The second fraction had a denominator of 10x squared y, so it needs to get multiplied by a y. All right, we go ahead and distribute. We get 4xy minus 8x and 3y minus 2xy. Now that our fractions have common denominators, we're ready to go ahead and combine like terms. 4xy and negative 2xy gives me 2xy. There's not another x to go with this one, so minus 8x. Nothing to go with that one, so plus 3y. All over my common denominator of 10x squared, y squared. Once we have combined like terms for this one, we want to check and make sure it doesn't simplify. Look at the top to see if it factors. Well, we don't have any GCFs, and this isn't one of those trinomials that's going to factor, so we're done right there, and there's nothing else we could do to it. Okay, on the next one, we have x squared minus 1 as one denominator, and x squared plus 2x plus 1. Both of these factor. X squared minus 1 factors to x plus 1, x minus 1. X squared plus 2x plus 1, that's a perfect trinomial, so that factors to x plus 1, x plus 1. Now we could come out to the side and make our L and look for our factors that way, but one of the easier ways to do it when you have denominators that are not monomials that have been factored like this is to look for what factors do they have in common if I look at those two denominators. Well, they both have an x plus 1 in common, so I'm going to mark that out from each of them. Now, do they have anything else in common? Well, there's an x minus 1 and an x plus 1, and those are completely different. So those are the two other things we need. We need another x plus 1, and we need an x minus 1. And that's our common denominator for both fractions. So you look for, what do they have that's the same, and what do they have that's different? If you want to write this denominator as x plus 1 squared times x minus 1, that's just fine. All right, now we look at this first fraction. It had an x plus 1 and an x minus 1. What did it get multiplied by? Well, it must have gotten multiplied by an x plus 1 in order to be made to look like our common denominator. So we need to multiply the top by x plus 1, which gives us 3x plus 3. On the second fraction, it already had two x plus 1s, so it needed an x minus 1. So we need to multiply this times x minus 1. That gives us 2x squared minus 2x as our numerator. Now we want to go ahead and combine our like terms. I'm going to start with my highest exponent, which was x squared. Is there another x squared on the top? Nope, so that's just 2x squared. Then I add my x's. I have a 3x and a negative 2x, which gives me plus x. And then I have plus 3. And on the bottom we have x plus 1 squared times x minus 1. You would want to check the top, multiply it out, and see if it factors to see if we could simplify. This one is not going to simplify, so I'm going to go ahead and box it, and we'll go on to subtracting.